Hi everyone. As we know that in the today's world, electric vehicles are gaining popularity, and in the electric two-wheelers, we have mainly three categories: two-wheelers, three-wheelers, and the four-wheelers like car and trucks. So the two-wheelers and the three-wheelers, electric two-wheelers and the three-wheelers uses a special kind of a motor, which is known as the brushless DC motor, or in short, it is also known as the BLDC motor. So in this video, we will see the types of the BLDC motors and their applications, and subsequently what are the models are available in Indian market, which is uses the different types of the BLDC motors. So before understanding the different types of the BLDC motor and their applications, it is imperative to understand that how the BLDC motors are different from the brushed DC motors. So here, as we can see that the first picture, this one, is the brushed DC motor. It is clearly visible that in the brushed DC motor, the power to the rotor is given through the brushes here. So these are the carbon brushes uphold here over the commutators, and the rotors are also having the windings, so the rotor windings are being supplied through the brushes and through the commutator part. Whereas in the BLDC motor we don't have the brushes, so it clearly gives an advantage that the limitations which occurs due to the brushes friction over here is eliminated in the BLDC motor. Moreover, the rotor in the BLDC motor has no winding, so here it is shown that this is the rotor of the BLDC motor, and it is of the permanent magnet types of the rotor. So in the BLDC motor we have the windings over only the stator, which creates the electric field, which creates the electromagnetic field, and therefore it starts rotating based on the principle of which we used to play in our childhood, that if we have a magnet and if we have two magnets, let's say, and both the magnets are of the different types, and if we move one magnet, the other magnet also moves along with it, because it has the attraction force in it, and therefore the same principle is also kind of being implemented in the BLDC motor. So here we can clearly see that the rotor is of the permanent magnet, having, let's say, the, as of now, showing the two poles N and S over here, this is, and on the stator we have the windings which creating the electromagnetic field, and this field is also is getting changes poles. So let's say here at this moment this pole is energized, so my rotor is getting aligned with respect to the pole is being generated by this winding, and the second instant this winding, and this instant in this winding. So it is simply like that, as we changes the pole over the stator winding by some external arrangements, then the rotor also tries to align its poles as per the stator poles, and therefore my rotors keep on moving. Whereas in the brushed DC motor, it works on the Faraday law of electromagnetic induction, where if I place the current carrying conductor between the magnetic field here, then it's experience a force and my rotor starts rotating. So let's quickly see the introduction of a BLDC motor after checking its how it is different from the brushed DC motor. So the BLDC motor is an electronically commutator motor. We know that the BLDC motor has no commutator or the brushes. However, the stator windings, this is the stator windings is being shown over here, and the rotor is shown over here with the two poles. This is the N pole, and this is the beneath of it is the S pole. So this is, and in the previous slide we have seen that the rotor was running in between the stator here, but here the rotor have surrounded the stator winding. So it also gives us the two types of the BLDC motor. that where one is the permanent magnet rotor is placed inside the stator winding, and the other one is the rotor which surrounds the stator winding. So this kind of a the rotor. So therefore, the this kind of a rotor is also known as the outrunner rotor. This is your outrunner rotor. So outrunner rotor simply where my rotor is surrounds my stator winding. So it is an electronically commutated motor where the stator windings are commutated electronically to just change the poles. Let's say here I have just shown the three poles or the three windings over the stator. Each windings having the two pairs. Let's say one, and let's say two, and let's say a three. So all these three windings will be commutated at the different times as per my requirement, and that is nothing but the electronic commutation. It also runs on the synchronous speed as this point states at, which is very obvious as I'm going to change my poles over the stator winding. Let's say as of now, at the first instant, I have energized this winding and have created electromagnetic poles over this winding. So my rotor will get try to align. So if let's say this is the N pole over here, so this S pole will get attracted towards this, and my rotor will start rotating in the clockwise direction. Similarly, if let's say if this is the S pole, so my this pole will get attracted towards this pole. So very obviously my rotor which is surrounding my stator windings will rotate in the clockwise direction. And the speed of the changing of these poles, let's say next instant I'm energizing this winding here. So my rotor will further move towards the this clockwise direction to align with it itself with the pole generated over here. So as quickly or the whatever this the speed of the changing of the poles over the stator winding, my rotor speed will be also the similar to that. So that's why it runs on the synchronous speed. Now here we need to pay the attention that there are three windings energizing at the different times, and it look likes that the BLDC motor will have the three wires and the fourth wire which is common uh, for the all three windings. So instead of two wire system like in the bridge to DC motor, the BLDC motor may have the four wire system. It looked like that it is a kind of a three-phase AC motor, but no, it is a DC motor, and DC supply is being given to the stator winding at the different times by the commutation process. And this commutation process is also defines the speed and the torque, how much speed is required, how much torque is required by the motor at the particular time. So commutation can also control the speed and the torque required by the motor. So as we have already set the tone for the different types of the BLDC motor, which is the outrunner motor. So this picture shows the outrunner motor where my rotor is surrounding my stator winding and it is rotating. The outer periphery of this BLDC motor is rotating with where the in-runner motor, this picture shows the rotor for the in-runner motor for with the different poles. So here it has a lesser number of poles compared to this picture which has the more number of poles. So this kind of rotor is placed between the stator windings, and it also known as the in-runner motor. We have one more type of the BLDC motor, which is the axial motor, where the stator and the rotor both are uh, uh, arranged axially. But the most widely used BLDC motors are the in-runner and the outrunner motor. Both motors find C applications in the two-wheeler, three-wheeler, as well as for the 3D aircraft or the drones. So now we'll see that how these two motors are different up in their characteristics and what are their applicability going forward. So this picture shows the two different types of the BLDC motor, in-runner versus the outrunner. And the red one motor is the in-runner motor, whereas the right one motor is my outrunner motor. So by just looking at these two motor, I can tell that which one is the in-runner, the outrunner. Here I can see that this outer periphery of this motor is being fixed and it is not rotating kind of a part, whereas it is clearly visible from this picture that this periphery over here, it is kind of a rotatory, and when I will just rotate this, when I will give the force, it will start rotating it. So uh, by looking at these two pictures or any motor pictures, I can say that which one is the in-runner and the outrunner. Specifically, I just want to draw your attention over here. In the in-runner motor, these are the ducts over here. So the stator winding is the outer part, and the inside we have the rotor. Whereas here the rotor is the placed, or it surrounds my stator winding. So whenever my permanent magnet rotor moves over here in the outer periphery, and my stator is being placed inside the rotor. So stator windings are producing the electromagnetic field over here by giving the external supply. So it generates the heat, and when that heat is tries to go dissipate outside, but my rotor is surrounding my stator winding and it is rotating also, so that heat gets trapped over here. It cannot get exhaust through the from the inside to outside. So therefore the heat gets accumulated over the shaft because it is being pushed by the rotor, which is running outside of the stator. So the heat gets pushed towards the shaft, and then it gets dissipated through along the shaft from these ducts over here, which is provided over here. So here it is clearly visible that the out outrunner motor has more ducts over here, or the bigger ducts over here, because it has the poor heat dissipation. Whereas in the in-runner motor, this is the red one is the in-runner motor, so it has the better heat dissipation characteristics because the stator windings are placed outside, and the heat generated by the stator windings gets easily uh, uh, gets towards the shaft, and there my rotor is running, so it has a better heat dissipation along the shaft. So as I've stated earlier that outrunner and in-runner motor both finds the application in the two-wheeler, three-wheeler, as well as for the other like drones and the aircrafts. So here the first picture shows the in-runner motor being implemented for two-wheeler applications. So the motor is placed over here in between, and it is being connected through the gear system and the chain system, and it is rotating my wheels over here. Whereas this is kind of a picture where the outrunner motor is being implemented for the two-wheeler application. The outrunner motor is also known as the hub motor, which is directly gets connected through my wheels. So it does not require any gear system or any chase system. It can directly get connected through the wheel. So uh, in comparison, we can say that installation of the in-runner motor for the two-wheeler applications required more components, or it has a more complex system as compared to my outrunner motor of the or the hub motor for two-wheeler applications. So let's talk about the performance differences for the in-runner and the outrunner motor. So uh, I have compared the in-runner and outrunner motor based on the 5 parameters over here. So first of all, the size. The in-runner motor, where the rotor is placed inside my stator winding, has a smaller diameter and it has a longer length. Whereas the outrunner motor, where the rotor surrounds my stator winding, so it has obviously large diameter. However, it has the smaller length as compared to my in-runner BLDC motor. RPM per volt or kV rating of the BLDC motor. So for the BLDC motor, the kV rating is, I would say, the most important parameter. The kV ratings says that uh, how much RPM it is going to rotate uh, per 1 volt. So therefore, in-runner motor has higher kV value. It means that per volt or 1 volt, let's say 1 volt, the RPM given by my in-runner motor will be more as compared to my out-runner motor. So the speed of, for the same size of my in-runner and out-runner motor, the speed of the in-runner motor will be more as compared to my out-runner motor. Whereas uh, on torque term, the in-runner motor has the lower torque as compared to my out-runner motor. So by just looking at it, the characteristics of the BLDC motor, that if I increase the speed, the torque gets reduced. So same thing is being also can relate over here, that in-runner motor has more speed for the same size, so it has the lower torque as compared to my out-runner motor, which has the lower speed for the same size, but it will provide me the higher torque for the same size. Heat dissipation, as we have already discussed, that in-runner motor has a better heat dissipation, whereas the outer runner motor is kind of a poor heat dissipation as compared to the in-runner motor. So therefore, this heat dissipation is also being transferred to my efficiency, that due to this better heat dissipation, the efficiency is comparatively high for the in-runner BLDC motor, whereas as compared to my out-runner BLDC motor. And as I've stated earlier, that both the motors find C application in the two-wheeler and the three-wheelers. So here I have taken some examples which runs on the in-runner BLDC motor and the out-runner motor. So like Ather 450X, TVS iQube, and Chetar Electric, these models use the in-runner BLDC motor, whereas the Hero Electric Optima, Okinawa Praise, and Ampere Magnus EX uses the outrunner motor. So where I need a low RPM and high torque applications, outrunner BLDC motor is more suitable. And whereas I need the better heat dissipation, the higher speed, and the moderate torque, then the in-runner BLDC motor has the more suitability. So in this video, we have seen the different types of the BLDC motor, their suitability, their characteristics also, the performance differences also. I will make a separate video on the working principle of the BLDC motor, how does it work, how the electronic commutation happens in the BLDC motor, and how my rotor rotates, and how the torque can be changed over the time. Thank you very much.